Alright guys, now we are going to continue the lesson with how we are going to sketch and explain the characteristics of Q against T and I against T graph for discharging process. So here's our previous notes. We want to relate what we have learned just now. Alright, now I'm going to show you a graph of Q and I. Okay, Q against I and Q against T and I against T. So we are start with axis first. Okay, I'll show you here. Okay. Right, so I have Q, coulomb, and here's T in second. If you still remember, just now we said that at first, voltage across capacitor is a maximum voltage. So we back to the formula Q equal to CV. If we have maximum voltage, our charge also maximum. So is our Q naught. Okay, so initially, as the electron flow, from plate B and goes to the plate A, it neutralizes the positive charge. So charge across capacitor starts to decrease because what happened? Actually, voltage drop. Okay, voltage start to decrease as the electron neutralize the positive charge on plate A. So Q start to decrease. Let's say I'm using the blue here. Okay, Q start to decrease until lastly it become 0. Okay, that's what happened to the charge. Okay, and this graph is exponential graph, so we can represent the graph with the mathematical equation. If you refer to the module, okay, your mathematical equation is Q equal to Q naught. Okay, Q equal to Q naught. Okay, Q equal to Q naught E negative T over RC. Okay, so the T here is referring to T at certain time. So this is a tau. Okay, this is a tau. And this is the maximum charge, total charge. And Q here is Q at certain time. Okay, this is Q at certain time T. Okay, now this is the equation that you need to know if we refer to the discharging process. Okay, so means that you must be able to calculate total charge that remain in the capacitor as the discharging process occurs at certain time. Okay, all right, now I'm focused to the next graph, which is graph current. Okay, which is graph current. So let me catch current graph here. Okay, so I have a graph current. My axis now, this is I against, okay, let me show you. And this is my current in ampere, T in second. Okay, for the process, your graph should have a negative part here, axis. Okay, why? Because we have told you before this that the directions of the current during discharging process is opposite to the charging process. So for the charging process, if you remember, the current is flow in clockwise direction during this charging process, the current flow in anti-clockwise direction. So since it's opposite to the charging process, so we have to show it with the negative direction. Okay, so the graph will be in negative part to show that the current flow in opposite direction during the discharging process. But when you do calculation, you can ignore the negative sign here, because the negative not referring to the quantity, is referring to the direction only. Okay, so I'm sketch for you about the graph. So initially, the current that flow during as the first time you close the switch, as the current is the I naught, which is a maximum current. So how we get the I naught? We back to the Ohm's law. You have V equal to IR. So if I need to determine the I naught, so V here should be the V naught. So you make it I naught as your subject. So it's V naught over the R. Okay, so that R might be the R effective for the circuit. So I'm going to sketch you. So we know that during the discharging process, when voltage starts to decreasing, the I also start to decrease until it reach 0. Okay, so how fast the capacitor decrease the current through the resistor flow? So it's based on the value of tau. So tau is equal to RC. We must have a standard value here based on 0.37% from its I naught. So if you want to know how fast the capacitor is being discharged, is based on the value of tau. So you calculate 0.37% from its I naught, then you can know the time taken when you extrapolate the graph, if you have the graph. Okay, so that's the graph of I against T for this charging process, and how we are going to represent this graph with mathematical equation. So we have I equal to negative, because in negative direction, negative exponential negative T over RC. Okay, so this is the equation. Okay, so this is the equation. All right, so as usual, T is a time that mentioned in the question. So I here means I at certain time. Okay, the I naught is the maximum current flow at first. So hopefully you know how to distinguish the shape of the graph. You know the characteristic of the graph for charging and also for discharging, and the definitions of the tau for both process. So that's all for discharging.